Hello everyone and welcome back to our channel Quaint. Today's topic of discussion is engineering the silence. No, not poetry. I am actually talking about phononic crystals in this video. Phononic crystals are materials designed to control sound waves. Just like semiconductors control electrons, that thing is known to you. Semiconductors control electrons. Similarly here, photonic crystals, these are actually engineered crystals. Normally 3D printing is used or nanotechnology is used to produce these crystals known as phononic crystals. So these are used to control sound waves. That means sound waves or the sound can be bent, can be trapped, can be redirected using such crystals. Even can be blocked. Okay, so can be trapped, can be blocked, can be redirected. So these things are possible. That means we need what? We need complete control over sound waves. So photonic crystals are those things, and those are what? Those are not found in nature, those are engineered materials. Normally 3D printing or nanotechnology is used to produce such things. These are what? Phononic crystals are actually, means you would find repeating patterns in them. Repeating patterns are there. That means phononic crystals are periodic structures. Okay, and they interact with sound waves, and when they interact with the sound waves, they create band gaps. Band gaps means these are certain ranges of frequencies where sound is actually forbidden to propagate. Band gaps means actually phononic band gaps. Phononic band gaps are what? These are actually ranges of frequencies where the sound is actually forbidden to propagate. Means sound waves having that range of frequencies are forbidden to propagate through the material. So this is what? This is phononic crystal. So these are engineered materials. So since repeating patterns they have repeating patterns, that's why when sound waves interact with them, in that case destructive interference can occur. Destructive interference. And since a destructive interference can occur, that's why band gaps are created. Destructive interference, those things are actually able to create band gaps. And that is actually our requirement. Our main requirement is what? Our main requirement is to control sound waves or the mechanical vibrations. Okay, so in case of architecture, you can find the use of this thing. Just imagine office walls, and behind the office walls, chatter is there, constant chattering is there. So in that case, if you want to block that unwanted noise, in that case, you can use these materials to build up your office walls. These phononic crystals. Again, if you talk about your smartphone, so there are electronic components inside your smartphone. Those are delicate components. And if you want to isolate those, means actually if you want to protect those electronic components inside your smartphone, in that case you can use phononic barriers. That means what? For the purpose of isolation of electronic components, you can use phononic barriers. Phononic barriers, that means you need to use phononic crystals to protect your smartphone or the internal components of the smartphone. Okay, that means in case of architecture, that is a requirement. Say in this room, I am right now recording my video, and I don't want unwanted noise from outside. So in that case, I can build the walls of this room by using phononic crystals. So in that case, unwanted sound won't be able to enter into this house. or into this room. Okay, again in case of earthquakes, in case of earthquakes, if you want to protect your buildings from earthquakes, in that case, so seismic waves are there. So scientists are actually exploring ways to use these phononic crystals at larger scale. In case of smartphones, that was not larger scale. But in case of buildings, you want to protect the buildings from earthquake. Okay, so in that case, you can use the phononic crystals at larger scale to redirect the seismic waves. If it becomes possible, then in that case, you can easily protect your house or protect the buildings from earthquakes. So you can see that so many uses are there of these phononic crystals. Architecture, then electronic components, then earthquake. So many uses are there. Okay, so and I have already mentioned that in today's technology, since technology is improving, and we are using actually right now 3D printing for many things, and phononic crystals are there. Again, phononic crystals are there, and in this video we are talking about phononic crystals, not photonic crystals. Okay, so anyway, fabrication techniques, there is an improvement in the fabrication techniques like 3D printing and nanotechnology. That's why we can say that we are entering an era where silence can be engineered using phononic crystals. Okay. Anyway, so this was all about today's topic, and if you found this video interesting, so please like, share and subscribe to our channel. This is the end. Thanks for watching.